Okay, so we'll catch up. So the first definition, terminating decimal, is a decimal whose division ends or terminates. Because what does the word terminate mean? To end. Okay, it stops. Alright? The opposite of that is a repeating decimal. And a repeating decimal is a decimal whose digits repeat in groups of 1 or more. So we could have a repeating decimal that's one number, like 0.33333 forever, or it could be a pattern. You could have 1212 or 125125. So it doesn't have to be just one number that repeats. It can be a pattern of numbers. So it could be 2 or 3 numbers. Yes? Yeah. Whenever we have a repeating decimal, you're going to see it written like this. Okay? You're going to have the number that repeats, or the pattern, and a line over it. That line shows that those numbers go on forever, that they are never ending.
We kind of knew that.
Good. Yeah, I think we did. You did some of this.
We didn't get like too deep.
That's okay.
Oh, we did it.
Yes. Who's in? I'm sorry. That's the word in. In groups of 1 or more. The digits repeat in groups of 1 or more. So it could be one number repeating, or it could be 4 numbers repeating. This is what shows up.
But like, couldn't you use like a post-it?
Could you use a red pen?
Alright, here we go. Let's look at our first example together. Okay? So we have 46 and 32 hundredths. And that is divided by 4 tenths. Now, the crazy thing about dividing with decimals is, guess what? You can't divide with decimals.
Yeah, that's true.
So with our divisor, what have we got to do?
Okay, on your divisor, you gotta move the decimal over to make it, your divisor a whole number.
Perfect.
And then you do the same thing on your dividend.
Exactly. So we've got to move this decimal to the end of our number as far as we've got to go to make it a whole number. So how many places will I move it here?
1.
Okay, so we move it once here. If I move it once in my divisor, how many am I moving it in my dividend?
1.
1.
To the right.
Okay? And then once I move it, I go ahead and bring that decimal up.
But I thought you couldn't.
Because I'm getting rid of the decimal in my divisor. I can do it in my dividend, but I can't divide with a decimal in my divisor.
I thought you did it until 46 had.
No, yeah, just your divisor.
Okay, so it's divided by 40. No.
Alright, so what I've basically done is multiplied both of these numbers by 10. When I multiply both of them by 10, it moves my decimal over one place. Okay? That way I keep the same proportions. Think about this. What's 10 divided by 1? 10. Okay, if I multiply both of them by 10, what's 100 divided by 10? 10. It's still the same proportions. I've just multiplied both of those numbers by 10. Okay? So let's look here. If we've got 4, how many times will 4 go into 4? Okay? So that would be 4. We subtract. Bring our next number down. How many times will 4 go into 6? Okay? So we put 4, subtract, bring our next number down. Alright?
25.
Well, how many times will it go? 5. That gives us what? 20. Okay? Subtract, bringing our last number down. How many times will 4 go into 32? Now, when I subtract, do I have anything left over? No, so my division ends, or it terminates. So this is a terminating decimal. There's nothing there that's repeating. Question?
So a repeating decimal is the exact opposite. So it's like where when you finish the last number, it has extra numbers.
Yes, and we'll do one of those in just a second. Yeah, because it's going to keep going, okay? All right, so this one ends, this one's terminating. The division is nice and neat, and we don't have a remainder, okay? Let's take a look and see what happens when we do. Everybody good? Ready to move this one up? Once you move your decimals, your divisions is the same as when we did it earlier in the year, okay? You're still dividing, multiplying, subtracting, checking, and bringing down. All right, let's look at the next one. Here we go. This time we have 496 thousandths divided by 1 2/10. So I've got to get rid of the decimal in my divisor. How many places do I move it? Once to the right. So how many places do I move this? 1. So I bring my decimal up.
Do you still use the 0?
I'm gonna. Great question. Do y'all see what she's asking? Do I still use this 0? So I'm looking at this number, and basically this number just turned into 4.96. Okay. So I'm looking at it. Well, I know 12 can't go into 0. Can 12 go into 4? No. I'm going to go ahead and put a 0. Now, technically, I don't have to, but I like to put that 0 there because it kind of says, hey, there's a decimal coming, but there's nothing in the whole numbers. Like a whole number will not go into that. Okay? Is it a question related to what we're doing?
Why can't you divide decimals?
Because I can't divide by part of something. Okay? So think about it if you have a brownie. All right? And you want to split it up, which is what division is. If I split it one time, I'm dividing it in half, right? So even making one split, one cut, that's still dividing one time. I can't divide less than that. Does that make sense? So I can't divide less than 1. So that's why I have to move my decimals to make sure I'm dividing by a whole number instead of a decimal. So no matter what, even if you cut it one time, you're still cutting it one time. So you're still dividing it by 1, or by 2 actually, because you split it in half. You can't divide less than 1. Does that make sense? Okay. All right, so let's go back and look. Can 12 go into 49? How many times? Try it again. 4. Thank you. Come on, it's late in the afternoon. All right, 4 times 12, that gives me 48. Now, here is where it is super important, guys, that my numbers line up. Because if your numbers are not lining up with where they go, your decimal could end up in the wrong place. So make sure that you are lining everything up neatly. Can 12 go into 16? How many times?
1.
Okay. All right. Now I have 4 left over. Hold tight. I want to say something real quick before you start yelling stuff at me. Okay? Hands down. I know you all have great ideas. I want to say something real quick. Have you ever heard of the word redundant?
Yes.
Okay? Does everybody know what an antique is?
Yes.
All right, an antique is what? Okay, it's something that's old. So if I were to tell you, oh, that's an old antique, I'm really saying the same thing twice, right? So it's kind of redundant, okay? So with math, we don't want to be redundant. Do decimals and fractions represent the same thing?
Yes.
Yes, they do. So now that we're using decimals, we're not going to throw a fraction remainder in there, okay? We're going to go ahead and change that into a decimal. And we're going to do that by extending our dividend. What am I going to add to the end of my dividend?
A 0.
Excellent. Does that change the value of my number?
No.
It sure does not, but it does give me something I can bring down. So can 12 go into 40?
Yes.
How many times?
6.
Ooh, back that up. 3.
49.
Okay, so that gives me 36. I'm going to subtract. Oh my goodness, look what's happening.
It's a repeating.
No matter what, every time I multiply, subtract, and bring down, I am going to get the same combination.
It's not a
Let's remember, guys. Okay? So these 3's are repeating. Every time I multiply, I get 36. I subtract that from 40. I have 4 left over. I bring a 0 down. It goes 3 times. Subtract 36 from 40. Have a 4 left over. Bring down a 0. It will never resolve itself. So this is what we call a repeating decimal. It is exactly the opposite of a terminating decimal. Okay? Alright, let's try one more before I let you start on homework. So now we have 45 divided by 4 thousandths. Remember, the first number will always go in the house. Okay? Your first number is always in the house for division. And your divisor is always on the outside.
What do you do with the...
Hold tight, we're going to get there. We're going to get there. So, how many places do I have to move it in my divisor? 3. So I'm going to move it 1, 2, 3 times. But now, do I have a decimal on 45?
No. So you just
Do I?
You have to do like it's invisible.
Say it again.
Invisible.
It is invisible. And where is it?
It's at the end.
Always at the end of a whole number. So I move it 3 times. What do I put in those spaces?
0.
Gotta have my placeholders. Okay? So now 4 will go into 4 one time. Subtract, bring the next number down. 4 goes into 5 one time. 4 goes into 10 how many times? 2. Still multiplying, subtracting. We'll move it up just a little bit so you can see. Bringing my next 0 down. 4 goes into 20. 5 times. That gives me 20. I'm running out of room, but if I have 0 left over, what's going to go up here? 0, because 4 can't go into 0. So we would end up with 11,250. Now, remember last week we talked about with multiplication, sometimes your answer will be smaller than when you started and how that's kind of weird.
Yeah, that's what I was fixing to add.
So look what happened to our answer. We started off with 45. But we divided it by 4 thousandths.
When you're dividing by fractions, it's basically decimal.
It's opposite.
Bingo. Did y'all hear that? Say it again.
When you're dividing by decimals, it's basically dividing by fractions and you get bigger.
That's right. So don't freak out. It is possible for your answer, now it could be smaller too if you have a whole number in your decimal, but it is possible for your answer to be larger than what you started with. Yes?
Why do you have to add a 0?
Right here because I ran out of room down here at the bottom, but if I had said 0 and brought my next 0 down, 4 will go into 0 times. That's the only reason I did. And I just ran out of room at the bottom. That's the only reason. Yes?
Oh, I was gonna ask, why don't you do this other 0?
After it? Well, I could do one after it, but I really don't have to because my whole number is going to end right there.
No, like on the 45.
No, but look, my numbers are lined up right here, 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 and here. Those are all the digits I need. That's why it's so important to make sure everything lines up just perfectly.
Because I was thinking, why didn't you do that 0 on the very end?
Right. No, that's just because that's where my whole number ends and I can stop right there because I don't have anything left over.
Alright, what's our homework?
Mm-hmm. 45. But think about what you started with. You started with 45 and you ended with 11,250. All right.